All right, so welcome back to the first question of CAT 23 slot 1 series. This question is totally based on logarithm. We'll learn some fundamentals of log, also use the log values. You should remember the log 2, log 3, log 5, log 7 to solve such type of question, because it's a very beautiful question, but you should know some approximation techniques for a competitive approach. So let's start. Let's read the question first. A lab experiment measures the number of organisms at 8 a.m. every day. Starting with 2 organisms on the first day, the number of organisms on any day is equal to 3 more than the twice the number of previous day. So if there are 2 on the first day, it would be double 4 plus 3, 7 on the second day. Then 7 double 14 and 3 added 17 on the third day. It is like this. Number of organisms on the nth day exceeds 1 million. Then the lowest possible value of n is how much? All right. So we see there is a pattern going on. On the first day, there are 2. On the second day, double and then 3 added, it is 7. Double and 3 added, it is 17. Double and 3 added, it is 34 plus 3, 37. And double and 74 plus 3, 77. Yeah, so this is the pattern going on. Now let's decode if there is a common pattern between two numbers. So the difference here is 5, difference here is 10. It is 20 and 40 and so on. So we can see the difference between the main sequence. The difference between two terms is a GP going on. So I can say this is our geometric progression. Let's revise the geometric progression. Let's just revise this thing. So the first term is A, second term is AR, where A is our first term and R is our common ratio, right? AR square, AR cube, this is our geometric progression. General term, how can you find general term? It is A, R raised to the power n minus 1. Sum of terms is A, R raised to the power n minus 1 over R minus 1. I hope these formulas are quite clear to you. Okay, let's just apply sum of terms in this question. According to the question, we can say this is our first day that there are 2 organisms. So 2 plus sum of GP is greater or equal to 1 million. So this is the fundamental that I have to apply here. Correct? All right, let's proceed. So 2 plus first term is, okay, now GP, focus on GP. GP is 5, 10, 20, 40. So the first term of GP is 5. I am writing 5 here. Ratio is 2. 10 divided by 5, 20 divided by 10. The ratio is 2 raised to the power n minus 1 over 2 minus 1. It is greater than or equal to 1 million. I think it is not exceeds 1 million. So it should not be equal to 1 million. It is always greater than 1 million. Okay. The value is greater than a million, not equal to also. Okay. So we'll just skip equal part. We just have to find greater than a million. That's it. All right. So here I'm saying if I just substitute n equals to 0 to cross check my pattern is right or wrong, I just substitute it here and see this value is coming out to be 2. So that is the first term of the main sequence. Similarly, if I substitute n equals to 2, it is 2 plus 5, 2 square minus 1, 2 minus 1. It is 4 minus 3, 15 to 70. That is the third term of the sequence. So yeah, we can say this, the thing that we have written in the blue is correct. It is matching our main sequence. I just cross check it. Okay. You do not have to do it in the main exam. I'm just saying here is so for the sake of simplicity, and also that you can also cross check if you want to. So this is our main sequence. Okay, so let's just expand the brackets here. The denominator is 1. It is 5 times 2 raised to the power n minus 5 greater than 1 million is 10 raised to the power 6. So I'm doing an approximation here. I will not solve 3. There is a 3 on the left hand side, minus 3 on the left side. I will just eliminate this thing because when you add 3 to a million, it won't affect much. Okay, so just eliminate that part. Do approximation. It is a million. Dividing by 5 makes sense here because it would be 2 into 10 raised to the power 5. Okay, I'll just apply log here. Now there is a fundamental of log, that log a raised to the power b equals to b log a with the base 10. So I just apply log on both sides first of all, and I shift the power. The power is n here. Yeah, one more identity I can say here is on the left hand side I will use log ab. That would be log a plus log b, because here I can see 2 and 10 raised to the power 5 are getting multiplied. So n log 2, 2 plus log 2 plus 5 log 10 with the base 10. This is a fundamental of log. So I divide by log 2 on both sides. It would be 1 plus 5. This thing is 1. Divide by log 2 with the base 10. Okay, so remember the values of log 2. 0.3010 for log 3 is 0.47. Log 5 is 0.699. And log 7 is 0.841. 845, sorry. So n is greater or equal to 1 plus 5 divided by 0.3010. And I do approximation here. That is 1 plus 5 divided by 0.3. So 5 divided by 0.3 or 0.3010. Again, you can do this thing approximation. It will be beneficial for this particular question. So this is n is greater or equal to 1 plus 5 divided by 0.3 is how much? 16.66. Yeah, so 50 divided by 3, is it 50 divided by 3? That is 48 is the 16 is the quotient and 2 is the remainder. So 16.66. 17.66 it is, and n is greater than 17.6 n is an integer, so n must be 18 here. But this n is a GP, is from GP. I have used this n from GP. We have to find the n according to the question, that this n, lowest possible n from the main sequence must be one more than this 18. It must be 19. So this is a quick approach for this particular question. If you try to find any other pattern, it will take hell lot of time and not good for a competitive approach. So I hope this question is clear. You can try this such type of question. Approximate the steps. You have learned these type of steps in your DI. Do the same thing in quant also. We'll see in the next video. Take care. Bye.